Velocity, we have said before, is a unique idea. It is the change in position in a given time or a period of time. We represent that mathematically with the symbol delta x over delta t. With that, we know that velocity is a vector. Vectors contain two parts, both a magnitude or the amount, a number, and the direction, either left, right, up or down, positive or negative. So when it comes to velocity, we like to draw a line above it. It means it's a vector quantity. So let's say we have, for example, you go 3 meters forward in 4 seconds and then up or 90 degrees at 4 meters in 4 seconds. Overall, we care about the start and end points. That pink line is our overall displacement, and we find the overall displacement is 5 meters. The total time is 8 seconds. So the overall velocity is 5/8 meters per second. The direction we see is that line, which has some angle, and from a 30, 60, 90 triangle, it becomes pretty self-evident. You can also see now there are individual velocities as well. 3/4 meters per second right and 1 meter per second up. So you have a person throwing a ball straight up and straight back down. We can kind of break this up into two middle segments. The up part and the down part, pink and green. For the pink part, is a positive displacement, ends up above where it starts, which is the positive velocity. For the other one, it starts at the top, ends down, negative displacement, negative velocity. Total velocity is 0, it ends back to where it starts. However, we could also say that there are velocities at every single point along it. Label them V1, V2, V3, V4, V5, all the way to like Vn, Vn plus 1, Vn plus 2. It's completely arbitrary. We're going to call these velocities at single points instantaneous velocities. It's not the average or the overall. That's what the main bottom and the main number at the bottom is. So these instantaneous velocities tell us a lot more. The two most important ones are the initial and final velocities, and possibly the top for a projectile as well. We're going to label these a lot. So again, looking at the situation, you can see if you pick 2 points that are kind of far apart in time, the instantaneous velocity between them becomes more like the average. Pick 2 points really close together, the time goes down, they become more instantaneously. So overall, as time decreases, the velocity you're looking at between 2 points always becomes more of an instant, less of the average. That's a limit argument. We could say the limit as time goes to 0 of the position over time is called the velocity instantaneous. And finally, for acceleration, our last major idea for today. We know acceleration is how quickly you change speed. But instead of the word speed, we got to use the word velocity because speed does not have a direction, velocity does. So acceleration is velocity over time, and since it's a vector, it's got to have magnitude and direction. So velocity is meters per second, time is seconds. Do the math, you get meters per second squared for our units. So let's say, for example, we have got something going 60 meters per second, and you can see right here that the velocity is changing every second. It's decreasing by 10. Therefore, the acceleration is negative 10 meters per second squared. Will it ever stop at the velocity of 0? Well, yeah, it could stop, but it doesn't have to stop permanently. It can keep on going and go backwards. So for example, let's say we start at 0, go to negative 10, negative 20. The acceleration is still negative 10 meters per second squared, but this in case it's speeding up because it's getting faster negatively. Come ready to school to learn, and I'll see you tomorrow.